morning friends, welcome to our online lecture series. Today we will be discussing numerical based on the topic number 1, which is motion. We have already discussed a few numericals in our earlier lectures. Today we will be discussing some of the numericals based on the Newton's laws of motion. So let's start with the numerical. First of all, we will note down the numerical, then we will try to understand the numerical. Okay, so let us start. Problem. A worker applies a constant horizontal force, constant horizontal force with magnitude 40 Newton, to a box of mass 80 kg, to a box of mass 80 kg resting on a frictionless horizontal surface. Frictionless horizontal surface. Full stop. What is the acceleration? What is the acceleration? What is the acceleration of the box along the horizontal direction? So this is the problem. First of all, we will try to understand the problem, what is given and what it has been asked to find out us. Okay. So let us start. The problem says a worker applies a constant horizontal force with magnitude 40 Newton. Okay. So first of all, we will try to understand what is given. So I write it over here, given data. So it has been given the constant horizontal force with magnitude 40 Newton, it has been given. So F is equal to 40 Newton. It's the magnitude of the force which is given. And this force, it is acting upon a box whose mass is 80 kg. So mass of the box is 80 kg. Now, this box whose mass is 80 kg, it is resting on a frictionless horizontal surface. This box is resting on a frictionless horizontal surface. So I like to focus on this word frictionless. So the frictional forces are negligible in this problem, so you don't have to bother about these forces. What is next? It is being given what is the acceleration of the box along the horizontal direction. So we have to find out acceleration. So acceleration is equal to question mark. Now, so that way if you consider this, it's a very straightforward problem. Force is given, mass is given, we need to find out the acceleration. So it is a problem based on the Newton's second law of motion, which is force is equal to mass into acceleration. But this we can say that just we have to use simply the force is equal to mass into acceleration. But how to actually, as this is a very simple problem, so you can easily solve it. But in order to, if the complicated problem it is given, so how to simplify such kind of problems? For that purpose, we have to make a free body diagram of a given problem. So in this problem we will learn how to make a free body diagram of a given problem. Now see, let us consider that this is an x-axis. Let us consider this is an x-axis or our horizontal surface. This is a x-axis. In which case, in this case, it is a horizontal, frictionless horizontal surface I am considering as an x-axis. At this point, this box is kept. Let us consider this is an point O. Let us consider this as an point O, at which this box is kept, whose mass is 80 kg, and a worker applies a constant horizontal force with magnitude 40 Newton on a frictionless horizontal surface. So your force is acting in this direction. So this is your force which is in this direction, whose magnitude is 40 Newton. This magnitude is 40 Newton. So your force is in this direction. Now if you consider the box is kept at the position O, what are the forces which are acting on this box? If you think in that way, you can realize that if box is kept at a horizontal surface, the acceleration due to gravity, it will exert a force. So there will be a downward force due to the acceleration due to gravity, and the normal reaction will be exerted by this horizontal surface on this box, which will be in vertically upward direction. So this is your normal reaction, and this force due to gravity and normal reaction, they will be exactly equal to each other, and they are in opposite direction, so they will cancel each other. Due to that, as this gravitational force and normal reaction, they are cancelling each other, so there will be no acceleration along the vertical upward or downward direction. So that is why our box, which is kept at this position O, it will accelerate towards the x-axis. So this is your free body diagram. This is a free body diagram which you should be able to generate for a given problem. In order to simplify the problem, this is the free body diagram for a given problem. Now, if you consider, as we had seen, the forces, we will note down over here, the forces acting on the box. Forces acting on the box are, number one, downward gravitational force. Downward gravitational force. Gravitational force which is acting in vertically downward direction. This vertically downward direction gravitational force, it is balanced by the normal reaction. So upward normal reaction. Normal reaction. And these two are exactly equal to each other. They are in opposite directions, so they will cancel each other. And the third force which is acting on this one, it is the force which worker is applying on this case, which is in horizontal x direction. The force applied by worker in x direction. In x direction. So these are the three forces which are acting. In these three forces, the first force and second force, they are in opposite direction, so they will cancel each other. So only the force, here you can write force 1 and 2 cancel each other. Cancel each other. So no acceleration along vertical direction. No acceleration along vertical direction. So there will be no motion along the vertical axis. So there will be motion along only the x-axis. Okay. So only the box will accelerate along x direction, and we can write from Newton's second law of motion, force is equal to mass into acceleration. We know that the force is a vector quantity. Actually, you should be writing it as F bar is equal to ma bar. But now we have considered that there is no motion along the y-axis. So instead of this, I'll just write over here Fx is equal to m into ax. I'll just write Fx is equal to m into ax. The force it is given, mass it is given, it has been asked to find out the acceleration. So from this I can write ax is equal to Fx upon m. So this is equal to Fx is what? 40 Newton. So 40 divided by mass is 80 kg. So it is 0.5 meters per second square. So you just have to simply write the one statement. The acceleration of the box along the horizontal direction is 0.5 meters per second square. I hope you people have understood this. Okay. Now we will move to the next problem. Similar kind of problem we will discuss. Okay. Based on the Newton's law. Okay? Let us start with the next problem. A man pulls a box of 12.4 kg. Pulls a box of 12.4 kg with a force of 40 Newton, inclined to the horizontal at an angle of 30 degree. At an angle of 30 degree. Full stop. As a result, the box accelerates. Horizontally. Full stop. What is the magnitude of the acceleration? Magnitude of the acceleration. Question. So this is the problem which is given. First of all, we will try to understand what is given in the problem, then we will try to solve the problem. Okay? Now, see, a man pulls a box of 12.4 kg. So what is given, that we will write first. So given data. Man pulls a box of 12.4 kg. So mass it is given, that is 12.4 kg. Mass it is given 12.4 kg with a force also. So force is also given, which is 40 Newton. Force is also given, that is 40 Newton inclined to the horizontal at an angle. So we just try to draw that figure over here. So let us say this is a box. Okay, this is a box, and there is a man at this position. For example, this is a horizontal surface. So this is a man. Okay, and it is pulling this, and this angle, what is there with the horizontal theta, this is 30 degree. So this is the problem which is given. So I'll write over here theta is equal to 30 degree. As a result, the box accelerates horizontally. So the box is accelerating along the horizontal direction. So we have to find out acceleration. As it is, the box is accelerating along the x direction. So I'll already in the starting only I'll write ax is equal to question mark, because it has been given directly the box is accelerating in the horizontal direction. What is the magnitude of the acceleration? That is why it is question mark. Now, so for this problem we will draw a free body diagram of the given problem. So this is a box whose mass is 12.4 kg. 12.4 kg is the mass of this box. 12.4 kg is the mass of this box, and this box is accelerating, is pulled by a person in a horizontal direction at an inclination of 30 degree. So for this problem, what I will do, I will make a free body diagram. So it's free body diagram. Free body diagram. Free body diagram. Now, in order to draw this free body diagram, what we will do, let us consider, let us say this is your x-axis, this is your x-axis, and let us call this as an y-axis. So this is your origin where your box is kept. Okay, so let us call this as a mass of object n. Okay, as this object or this box is pulled at an angle of 30 degrees. So let us call this as a theta is equal to 30 degree. So your force is in this direction. So your F is in this direction, whose magnitude is 40 Newton. The magnitude is 40 Newton. As we had seen in our earlier problem, in this case also there will be a force acting in vertically downward direction. So which is due to the gravity. And the surface, it will exert a normal reaction which will be in the vertically upward direction. So obviously this and this both will be equal in magnitude, so they will cancel each other. Okay, so this, now see, we know that this force is a vector quantity. This force is a vector quantity. Now, in order to find out the result of this, we have to assume that the vector, any vector, if it is there, it can be resolved into two components. For example, let us call this as an x-axis, let us call this as an y-axis, let us call this as an some point P, and let us call this as a vector r. If it is there and if this angle is theta, draw a perpendicular from this point to this point. If I say that this is my x coordinate, this is my y coordinate, then this distance PQ or OQ, it will be x, and this PQ, it will be y. If I use a trigonometric function over in this triangle, if I ask you to find out the sine theta, so what is sine theta? Sine theta we calculate as opposite side upon hypotenuse. So a side opposite to theta is PQ. PQ is nothing but y. So it is PQ upon hypotenuse is OP. Okay, so it is y upon r. Similarly, if I ask you to calculate the cos theta, it will be what? Adjacent upon hypotenuse. Adjacent is OQ upon hypotenuse is OP. So this will be nothing but x upon r. X upon r. Now, if I transfer this r from this side to this side, it is divided on this side. If I transfer on this side, it will go at this point. So it will become x is equal to r cos theta. Means x component of any vector, it is always r cos theta. So here in the same case, if I draw a perpendicular from this, so this component which I will be having in this direction, it will be f cos 30 degree. So the horizontal component which will be there, it will be f cos 30 degree. So here in this case, horizontal component of the force, horizontal component of force is f cos 30. So from second law, force is equal to mass into acceleration. Force is equal to mass into acceleration. So in this case, we have to find out the acceleration. So if I transfer this acceleration on this side, it will be force upon mass only. And the horizontal component of the force is f cos 30. F cos 30 divided by mass is 12.4 kg. 12.4. The value of force is 40 newtons. So it is 40 into cos 30 is root 3 by 2. Root 3 by 2 into 1 upon this will be 12.4. If you simplify this on the calculator, you will get the final answer to be 2.79 meters per second square. Calculators are allowed in the exam. If you can use the calculator, just be sure while using a trigonometric functions value, you need to choose a particular mode, because here in the cos, the angle is given in degree. So while using the calculator, you have to use it properly. I hope, and finally you have to just write a single statement. The magnitude of the acceleration is 2.79 meters per second square. I hope you people have understood this. We will come with a few more problems in the next class. Thank you.